Hello and welcome to Buttpluggin with qDot. It is me, qDot, Kyle Mishulis, here again in self-isolation and ready to spend a while talking to you about remote sexual intimacy via technologically mediated hardware sources, which is just the really super fancy way of saying internet butt plugs. So yeah, if you missed out on part one, it is up on YouTube right now. Don't worry, like you're not gonna be completely out of the loop today. I'm gonna be reviewing the important parts of that for today's episode. For today, we're gonna be talking about two different things. So the first off is going to be figuring out what we want when we are building what I'm calling a simple teledildonics application. So how do we scope this for who our users might be and to be able to build on it later? Because for Teledildonics 101, we're just going to build this simple app. And for anything after that, we're hopefully going to build on top of this. So we can start hooking like chat services like Discord or Telegram into this, or possibly using it to mod online games. For instance, right now, doing this live stream is keeping me from playing Neos VR, which for some reason I am fucking addicted to now. I just love me a virtual world, gotta say. So we'll definitely be hooking up stuff in there at some point too. Yeah, so today is going to be scoping that app, and then the second half is going to be a quick discussion of Buttplug. So Buttplug is the open source sex toy library that I maintain. You can find out more about it at buttplug.io. Buttplug is this is made for developers who want to write software that accesses sex toys. Right now, if you want to do that, or well, before Buttplug existed, if you wanted to do that, you needed to know how to access things like Bluetooth and USB and serial, all on like all these different operating systems and platforms. And with Buttplug, we take all of that out of the way for you, and we also implement all of the proprietary protocols for different toys. So we support something like 140 different toys right now. If you go to iostindex.com, this is a website that is a database of different computer-controlled sex toys. It has 250 devices if you actually choose availability. Overall, there's 366 devices listed throughout history. So that includes devices that are not even in production anymore, like the Real Touch, the Virtual Sex Machine, the Safe Sex Plus, so on and so forth. And if we add a filter there, we can actually see which of these toys has Buttplug support. And right now, yeah, 139 toys. So anyways, we're going to be using Buttplug in later episodes to implement sex toy control in this simple teledildonics app we're building. So today, not any code, just talking about how Buttplug works. Let me also... okay, I think we're good. So, back up here. And yeah, so today's going to be mostly me talking over slides again with a few toy demos and whatnot, but that's pretty much it. I expect this to last about an hour to an hour and a half. And if you have any questions, please feel free to ask on either the YouTube chat, or you can DM me via Twitter too. My name will show up down here about once every 3 minutes or so. But you can DM me at either qDot or Buttplug.io on Twitter, or if you want to join our Discord server at discord.buttplug.io, I'm on there too. Trying to watch all of these while also doing this video, so kind of got a lot going on. But okay, without further ado, let's get into this. So, yes, Teledildonics 101, Application Design and Buttplug Overview. Welcome to the next part of this lecture. So Teledildonics 101 is a 4-part series going from what even is teledildonics, and what is the history of it, and how do we talk about, or well, how do I talk about teledildonics apps? It turns out not a lot of we there. There's not a lot of people making teledildonics applications yet. That's why I work on Buttplug is to try and get more people interested in doing that. So part one covered that history and how we analyze teledildonics applications. Part two is going to be is what we're in now. So, and I already just talked about what we're doing there. So, quick recap of what's going on overall with these videos, though. First off, why am I doing this? Well, I am qDot, or Kyle Mishulis. I am the founder and CEO of a company called Non-Polynomial. I don't know, I'm so used to writing Non-Polynomial Labs because that has been the name for the past 14 years, but earlier this year we went to being just Non-Polynomial. I am also the project lead of Buttplug. And then, yeah, I do a whole bunch of like engineering and blogging and stuff too, but basically I've been in the sex tech industry, in or around the sex tech industry for 16 years now, mostly on the consulting and research side. I don't do a lot of product development myself outside of the software stuff, but yeah, so that's why I'm here and why I'm doing this. This is the Teledildonics 101 series. I already went over that part. So we're going to be building the Teledildonics app that we are building. Is going to actually be on the web, but you can do it as a desktop or mobile app too. We do have the availability to do that in the library. It's just right now the web is easiest to show off to everyone, and it's the quickest to get onto everyone's machine. So that's why I'm working on that right now. But if you're interested in a mobile app or a desktop app or something like that, definitely get in touch. This can be ported and has been ported other places. Or you can even, if you want to do best of both worlds, where best still involves Electron, you can always just case this up in Electron and go, because Electron is just Chromium. So all the videos in this series are Creative Commons licensed using attribution and share alike. So there is no non-commercial license in there, so you can show this wherever you want. Definitely want this information out there. It will be archived in multiple places. I run on YouTube right now because that was the live streaming service I have set up, but there's no telling how long I'm actually going to last on this service. I am talking about adult subject matter, and none of us are ever quite sure how long we're going to last with YouTube and that kind of content. So I will also be uploading these to Pornhub, Internet Archive, possibly Vimeo, just to make sure that the information is out there in as many places as possible. And then finally, all the information that I am presenting here, including like references to books and articles and things like that, as well as hopefully at some point actual transcriptions of these videos, and I'm hoping to do closed captioning too, will all be available at buttplug.io/videos. Right now there's just a little stub web page there. So okay, if you need to get a hold of me and you haven't caught the things that are scrolling down here on the screen yet, down here on the screen yet, here is all my information. You can get a hold of me at any of those 3 Twitter accounts. There's our Discord server, which has over 1,000 people on it, talking about different sorts of DIY sex tech. There's a Telegram channel that is mostly furries shocking each other. It's Telegram, but at least the stickers are good. GitHub, I've got a few different GitHub accounts. The one that you're mostly going to be interested in for this are the Buttplug.io and Interface GitHub orgs. Those contain a lot of the code that I'll be using here. And also we'll be using the glitch service to distribute our Teledildonics server application when we're done. Glitch is a online JavaScript sharing project site. So the nice thing is I'll just be able to make the project in there, and then you'll be able to go hit a single button, fork it, turn it into whatever you want. It's yours to do whatever you want with. Everything will be BSD 3 clause licensed, which means all you have to do is like maybe put my name somewhere. But that's about it. Finally, I do have a Patreon. First off, with times and things the way they are, please don't worry about giving me cash first. Tip your service workers, tip your gig workers, help people out that need it more than I do. I'm a tech worker. I'm still doing my day job right now. I'm still pulling a paycheck. I'm fine. However, for those of you that are in the sex tech business or that are interested in updates specifically about that, I do a weekly newsletter where I talk about what I'm doing and maybe sometime, and also sometimes what's happening in the industry or who I'm interacting with and whatnot that I can talk about. So if you are interested in that specific information, feel free to sign up to my Patreon. And if you want to do some free help for me to, of course, smash those like and subscribe buttons, because I'm just not a YouTuber if I don't say that too. Okay, let's recap what happened in part 1. Talked about the history of Teledildonics. I talked about a framework for teledildonic app analysis, and I'm going to be covering the steps of that here in the next couple of slides. What we're going to be talking about today, as I've already said about 16 times now, designing a simple teledildonics app using our analysis framework from part 1. So I'll go over that again, and then we'll walk through the steps of each element of this framework. How do we think about it when we're making our new teledildonics app? And then finally, the Buttplug architectural overview. So you'll be familiar with the terms that I have created around the Buttplug architecture. For the only slide in this presentation that does not involve a Buttplug, I've been using PowerPoint's slide generator service, and it was this deck. It's just lots of large butt plugs, unfortunately. Unlike the Teledildonics 101, the part 1 version looked pretty good. This one got a little samey after a while, so I decided to add a computer icon to one of these, and for this one it works. So this is our Teledildonics framework review. The Teledildonics framework analysis framework is when we are talking about a teledildonics situation. How do we look at it? What parts can we break it down into, and how can we analyze those parts? And then when we build a new application, how can we take all of these parts into account to make sure that what we are building will do what the user wants it to? So there's 6 parts to this, 6 or 7 parts to this that I'll be going over, and then we're going to go through each one in depth, talking about our new application. So the first and most important part of the Teledildonics analysis framework is always the user. Whoever is using your application has to be the core of your design. And the more vague that person becomes, the more you kind of have to develop for the mainstream, the harder this gets to analyze. Also, this can turn into a complexity of how many users are there at once too, because that actually divides the attention of the user if they're like working with a group, or they need to go find, like they need to find someone to use their toy with or something like that. So developing for the user and concentrating on the user is kind of the number one place to start. From there, we can go to their environment. Where is the user when they are using your Teledildonics application or hardware or both? Are they sitting at home? Are they out in public? If they're sitting at home, are they in an environment where they can't let other people, excuse me, they can't let other people know that they are using the toy, at which point the hardware becomes a factor because it could be too loud or it could be too hard to hide or something like that. The environment around the usage of the toy certainly matters and needs to be taken into account when we're doing this type of design. There's the link between the user and the toy, or what I call the user-toy interface. So the user-toy interface is like, how does the user turn the toy on? How does the user make sure that it's in the mode that the computer can talk to it? Also with toy user interfaces, how does it actually fit on or in the user's body? Because that's definitely important too. If things get in the way, if your hands are all looby and you can't hit the buttons, or you can't move to the keyboard or whatever else because of the way that the toy needs to be lubricated or something like that, all of that matters because that may affect how you design your controls later. It may also be that you don't know what toy your user is using. If you're using Buttplug and you support everything that we do, then you've got a really big question there, and you may have to divide that up into smaller parts. The next part of the framework after that for analyzing teledildonics applications is the toy-computer interface. How does the computer talk to the toy? What is the protocol that the computer uses to actually tell the toy to do things? This makes a huge impact on usage, because if you don't have control over the protocol, if you're using a commercial toy or something like that where you didn't write the firmware, you may not have a lot of say over this. And this can really hamstring how you do things. For instance, the fleshlight launch, which I have right here. This thing. So the fleshlight launch, its protocol actually, you have this like random speed, and you can say go to a position at speed. But the speed doesn't mean anything. It's just a number between 1 and 100. Your position is between 1 and 100. You can't say what distance that, or you don't know what distance that is, and you don't know really upfront how long it's going to take at what speed to get from point A to point B, which really kind of kills most of computer control. Because if you can't predict where a thing needs to be at a certain time, how do you map animations to it? How do you map movement in a movie to it? And we've done some work to, the sex toy community has done some work to figure that out themselves, but Kiru fucked up big time when they made that control protocol. However, things like the Lovin's protocol, this is a Lovin's Nora, pretty easy. You just literally send it a string that says vibrate and then a number between 0 and 20, and those are your vibration levels. Pretty simple to do there, but vibration's much easier to deal with than linear movement. So that's kind of an idea of what we deal with when we're talking about toy-computer interfaces. Next is the user-computer interface. So what is the user doing on the computer to control the toy? So this is the land of applications here. Do they need to move sliders? Do they need to play a game? Do they possibly need to do nothing, and sensors on the toy are like accelerometers or something else are controlling another person's toy or a game or something like that? And then there's the link between two computers. So in a remote situation where a person or multiple people want to control a person or multiple people's toys, how do we write the protocol for whoever is the controller to get their data to the controllee in a way that is safe and sane? That's a super hard problem. This is where a lot of the security issues lie. So we spend a lot of time talking about this here. And it's considered that this is a symmetric framework for now. And by that, I mean, when we're talking about the Teledildonics application, we're going to figure that we're only going to work with two people up front for right now. And we're going to figure that both of them are in similar situations. That's almost never true. But right now we need to add 2 plus 2 before we get into like the multivariate calculus of creating a full multi-user teledildonic service. So that's kind of where we're starting with right now. So you don't need to think about asymmetry between users too much at the moment. We're going to try to minimize that, but we will get there, and oh my god, it's so difficult. So what are we trying to do with teledildonics and really with remote intimacy in general? And this is a idea that I call Proxemic glue. So a teledildonics app or a remote intimacy app, be it remote, like via a dating app or cam modeling or a dyadic social network like Pair or something like that. There are actually little social network apps that you can get that are just for two people. Like they're a social network for a couple. So all of these are types of digital remote intimacy. And what are these things doing? Well, they're trying to bring two people closer together. And why are they trying to bring two people closer together? Well, there's a whole field of study around that. There's this thing called Proxemics, which is the study of nonverbal communication via spaces, via bodies and how they inhabit spaces. So if you ever heard of like personal space or something like that, that is an idea that came from Proxemics. It was created in the 1960s. It's still used today to talk about some types of sociology and whatnot. There's actually some fantastic books out there right now, including this is John MacArthur's Digital Proxemics. Fantastic overview of dealing with proxemics in the digital age. Everything from geographic level, GPS and whatnot, mobile, how we deal with our bodies and mobile interfaces and whatnot. Highly recommend it. But anyways, getting back to our app design, Proxemic glue, and the reason I call this Proxemic glue, let's go back to the horrible image I drew of Proxemics in the last video here. So here we go. So let's say this right here is you and your body, and everything coming out from this is different distances. So we have the public distance, which is like people doing public speaking, social distance, which is you talking to another person from a decent ways away, personal distance, which is like you possibly being close to sitting next to someone that you feel a little bit more comfortable with talking to. You might be close to them. And then finally, intimate distance, which is touching, kissing, fucking, so on and so forth. So when you build an intimate app, really kind of what you're looking at doing there is trying to get, like I said, users closer to each other. And your app, unfortunately, right now will not teleport their bodies next to each other. We're still a couple of weeks away from that. So what we have to do is create the interface to make them feel like they are close. You have to build the best experience you can to get their brain chemistry going, to possibly augment senses via audio, video, haptics. We don't really have much in terms of olfactory and taste yet, and the technologies we do have for taste and smell on computers are not good right now. So you kind of have to use what you can there. And this is why I call this Proxemic glue. Close is good enough in horseshoes, hand grenades, and whatever app you're building. So if we go back here to the my horrible drawing here. So this is if this is your user, you as an app developer are like somewhere out here. And what you're trying to do with your app is if you kind of look at this as like a track and field thing or something, let's say you're trying to do like a shot put or a hammer throw somewhere into this. And you have, instead of just getting it as close as possible, you have a distance you want to hit. So if you're Twitter or Facebook, you're kind of fine with this public space because Twitter or Facebook are about broadcasting. They keep saying they're about bringing people together, but when you're talking about hundreds of millions or billions of users, and each one of them has a local network of hundreds of people, it's still a broadcast thing. You can't fit hundreds of people within 4 to 7 feet or 7 to 12 feet of yourself. So it's always going to be in this sort of larger, more impersonal realm. And people try to get, you can get closer than that. Like if you're looking at dating apps or those might try to land you in the personal or the social or maybe even the personal. However, what we are implementing here is a Teledildonics app. So while for those other types of apps, they're not trying to get that maximized distance, for a Teledildonics app, we are like right here. Like we are right next to that user. We need, as Teledildonics app developers, we need to build an interface that basically is the space between two bodies that are engaged in sexual intercourse. That is what I mean by proxemic glue, is like we have to fill that space in such a way that it kind of sticks the two users together in the way that they're looking for. And the more, weirdly enough, the more space that you have, kind of the easier it is to do that, where we don't have any of that space. We need those bodies to be up against each other, bumping and grinding via whatever hardware it is that they've bought to work with our software. So this is an incredibly difficult problem. And that's why, instead of just jumping in and doing this code, I'm spending the first 2 full episodes just talking about theory right now. Because if we actually think about this from the theory standpoint, it gives us a way to make sure that our app is doing what we want it to. Because if a user comes along and tries to have sex using your application that you've told them they can have sex using, and it doesn't work, oh my god, they get really mad. So that's kind of what we're doing here. So let's talk about what our simple Teledildonics service is going to be. Let me just say hi to the chat here real quick too, see if anyone is alive. If you are around and on chat, please say hi on YouTube. Just kind of want to make sure people are alive here. So we are talking about, our simple Teledildonics service. This is what we're going to be building over the next couple of lectures. It's going to be dyadic, which is the sociology term for just 2 people, one on each. So we figure there's going to be 2 people remote from each other, and by remote I mean they could be in the same room, but they're on 2 different computers or phones or whatever else, using 2 different toys. That obviously this is not a generalizable situation. People are going to want to use toys in different ways than that, but once again, let's add before we get into the crazy math. Simple toy sharing. So you're going to be able to say, okay, I have, say, a Lush and a Nora and a gamepad. But I would only want other users to be able to, say, access this. So Buttplug will try to connect to all of these if you have them on. But we want to be able to say the other user can only touch this toy. And the way that the other user will be able to control that toy is probably just through a slider bar. For a vibrating toy, that just means you'll be able to control the speed. For a toy that does linear movement, you can control the oscillation length and the speed of the oscillation. And for a rotating toy, like, say, for... oh, hey, guess whose Nora's out of power. Okay, well, this thingy right here would go around this way if this were going to rotate. So, we can actually set rotation speed and direction, or there's, like, this is the Vors A10 Cyclone SA, which... you put sort of an own-hole or fleshlight in and it turns it back and forth around a penis. This also can go and it can rotate in both directions at different speeds. So those are our 3 major movements at the moment: vibration, stroking, and rotation. We'll be adding more to that. It's actually fairly soon, but that'll keep us pretty busy for today. So we want our communication in this app to be peer-to-peer if possible. But we have to figure out a way to link those peers first. So we're still going to need a central server. To jump ahead just a tiny bit and explain that in some very technical terms to make this go quickly, we're going to hopefully start with WebRTC, which allows 2 people to talk to each other. It's usually used for video conferencing, but you can ship data over it too. I'm just planning on using the Peer.js library. However, I'm probably also going to set up two versions of this project, one using WebRTC and the other using a centralized WebSocket server. The WebSocket server gives us a little bit more extensibility, and so when we want to start building APIs for games or chats or whatever else to hit, we can do that. And all of this can run under Glitch is the wonderful thing. Okay, so if this is simple, what is considered complex? Complexity comes not... It's going to be how do we multiply what we build here. So, for instance, a multi-user central server, like Lovense, for instance, right now. If you're using the Lovense app, you're connecting to the Lovense site. Hundreds of other people are connecting to the Lovense site too. They all need to find each other, and Lovense themselves has to make sure that all of those connections stay private. There's a lot to think about when you're bringing everyone to the same table, but you only want certain people to be allowed to talk to each other. And this also requires account systems and ways to figure out how people are going to match. The system we're going to build is assuming that the users are talking to each other through some other means. We are not building like a chat into this or something yet. This is just going to be toy control. So we're just doing the one thing that we do well and letting some other service handle that. Now, is that the best choice in the long term? That's kind of questionable because it depends on how you're going to interact with your toy. You may not want to be switching windows to make sure something controls something or whatnot. With a web browser, if a web browser gets backgrounded or if your tab gets backgrounded, you may lose your communication fidelity too, which means you might get one update per second versus 10 to 20 or something. There's lots of stuff to think about there. Like I said, yeah, way more security and interface requirements. And it's not that it's bad, it's just I would like to do something simple first, and then we'll go from there. So I believe the next slide gets us into talking about what we're doing. So to give you an overview of kind of what I'm thinking this application is going to look like, let's go back over to the web browser here and pull up an application I wrote called Buttplug Playground. So Buttplug Playground is at playground.buttplug.world. This is an application that I used to sort of test the Buttplug.js library. This is a single user application that allows you to connect your toys to the web browser either via web Bluetooth, so purely in the browser, or via our interface desktop application. And then you can just control the toy. So it's a pretty simple test application. In part 3 of this series, we're going to build a very simple JavaScript ES6 version of this. Buttplug Playground itself is a TypeScript application written in Vue, and if I want to keep this to be a simple Teledildonics server, I don't really want to get things like Vue and Webpack and things like that involved, because then you have to be a full like front-end dev to understand that. And so I'm hoping to just make an index.html and a JavaScript file, and we'll call it done. And you could do that with this too. So to give you an idea of what this looks like, we're going to connect in browser here, which just means we'll run all of Buttplug in the browser. The Google Chrome browser and anything that is running on the Blink engine can usually hit Bluetooth on Mac, Linux, Windows, and Android. So that means that we can actually access sex toys through the web browser directly with no other install. Super handy. The only kind of odd platform out there is iOS, and I'll cover this as a full slide in one of the later lectures, but there is a WebBLE browser in the App Store. It's literally called WebBLE. It runs the kind of crappy in-app browser, but somehow managed to polyfill Bluetooth. Most of our apps do run on it. It's kind of jank, but it does the job if you're stuck on iOS. Anyways, so let's hit connect in browser. And it instantly brings up a dialog that you cannot see. Fantastic. Let me create a new scene real quick that it just captures. Okay, sorry, I forgot to put in my audio source. Um, okay, so let's do that once again. I'm gonna hit reload and redo that. Sorry for people who are watching this archive later. That was a bit of a bump. Um, so now that you can hear me, this is my Levin's Lush. This is Playground. And so what we want to do is hit connect in browser, which allows us to run everything in the browser here. And then we will connect to this Levin's Lush that I have here. So there you can see the light that's flashing right now. This is going to go solid when I hit connect. So there it goes, went solid. And now we select it in our device list, which means I want to control this toy from Playground. And then here you can actually hear it in the mic probably. Yeah, looks like it's coming through. So now we can control the speed of this thing in real time through Bluetooth through the web browser. So this is what we're going to be building for users for a Teledildonics application. It's going to look mostly like this. It won't be quite as pretty because this is using a Google material design theme for Vue, but it'll do the job and it shouldn't take that much code. And then what you'll be able to do is also back in this menu, there will be some sort of way to say connect to this server or connect to this user. Once that connection is up, then whenever you select a toy, there will be some sort of checkbox either in there or out there that says let user connect toy, and it will reflect this UI over to that other user, and they'll be able to move the slider bar too. That's it. That's simple Teledildonics. That's about as simple as you can get. It's an app structure that has been around for decades. I mean, this is going to be similar to what toys like Highjoy and Simulate could do in the mid 2000s. So nothing new, but it'll be all open source, and the hope is that when you have that application, you can fork it on Glitch or whatever else, you can take it and do whatever you want with it. And build your own thing out of it. That's why I want to make it simple, is so other people can extend it, play with it, fuck it up, whatever. So getting back to what this app is going to be doing from the perspective of our Teledildonics application analysis framework. Let's talk about the user first. The user is just going to be someone who wants to share their toy with another user. That's it. Pretty simple. We're going to assume they have another communication method with that other user than just our app. There's no chat in our app. There's no video or audio connection. It's just get the toy information out there and then let other people control it. That is it. I don't want to be Skype. I don't want to be Jitsi. I don't want to be Zoom. I don't want to be Discord. I don't want to be Telegram. I just want to do the one thing I'm good at. And then after that, we'll grow from there. And we're also kind of going to assume that there is that the users are somewhat technically savvy. What this really means nicely is I'm probably not going to write a lot of documentation about this, and it's going to be pretty hacky. But how you present this to a user and how you get them comfortable using it is another long discussion. That definitely needs to be had, but I'm kind of trying to keep to the technical side, and also that's a discussion that's going to change depending on what communities the user might be interested in. So that's why this is kind of a generic white label thing for right now. What I'm hoping people can do is learn how to do this, take it back to whatever relationships or communities or interests they have, and form it to their own interests versus me trying to build for everyone, because it can work, but it's iffy. Okay, talking about the sorry, having some movement troubles here. There we go. Okay, these slides are Trying to stay out of the way of my own slides. So, the environment. What is the environment for usage for this app we were building? It is in a web browser. And so that means the user's computer stays mostly clean outside of the browser history. So unless they need to use Interface Desktop, which like you would need to do if, say, you want to use Firefox. Firefox does not have web Bluetooth for reasons that I could fill about 8 hours in. And if you wanted to use Firefox to access our application, you would need something outside the browser to do the Bluetooth stuff, and that's what Interface Desktop is. But the application we're building could probably pretty easily support that. I might do that depending on how much time the part 3 and part 4 talks take. But for now, hoping it's just Chrome or Brave or one of the other, or Edge has web Bluetooth in it too. But it's a browser, so you'll already have the browser installed. You'll just need to go to our URL. You can do it in a private or incognito mode. And this is also going to have to be hosted on a server with HTTPS because web Bluetooth is secure context requiring. So there's some security in there and some ability for the user to kind of dodge people knowing whether or not they're using an app like this if they want to. And that's it for the environment. That's like, we don't know much else about like where they're going to be using it from or anything else. This is kind of really all we can plan for. So now we get down to the user toy interface. We don't have much of a say here. We're going to support toys that vibrate, toys that rotate, toys that move back and forth, and we can provide them with ways to control the speed of that. Or ways to control oscillation length and stuff, like I said. But that's about it. We don't really have a say over you will use this toy and you will do it this way, outside of the fact that we're handing them a slider to do this with, which possibly not the best UI, but it's something. The one thing that we're missing there that most toys do actually support is playing back patterns. For instance, all these Levin's toys like have patterns built in, and there are commands for that. We don't have the capability to do that in Buttplug yet. It's coming in the next version, which will hopefully be out sometime in the next month and a half. At which point you'll just be able to say play pattern 6, and it'll actually have a name you can see and whatnot. And that's super helpful too, because that means you don't have to be sitting there changing things. You can just say play this pattern and then go do whatever you're gonna do too. But that's kind of really all. Like, we don't have any say over the buttons or where the user is going to be putting the toy, or not only do we not have a say over it, we don't even know, and we may never know. So not a ton we can do to plan there, but knowing that we can't plan there is still planning. The toy computer interface. We don't get much of a say here either because we didn't build the toy. So the user is going to come to us with this toy that they hook up over Bluetooth, over USB, over serial, over something like that. And all we can do is identify it and go, yes, we can talk to it, or no, we can't. That's kind of all we can do. And the thing is, Buttplug is going to be taking care of that part for you. So Buttplug will figure out, like, how do I find this toy on the computer? How do I look it up on Bluetooth or whatever other bus it is? And then how do I talk to it? For the user computer interface, this is the application. Simple website, a lot like Buttplug Playground, which I just showed you. This will allow the user to start a Buttplug instance in the browser or an interface instance if they need to use desktop, find their devices, and select which ones other users can access. It'll allow local control too, so if you want to turn off someone else's access and then stop the toy or something like that, you totally can. So it'll have all of the same functionality as Playground. It'll allow remote what I call remote override of local control, because that's what it is. Like, you're saying you are giving your trust and your consent to this other user to be able to control something that is intimately connected to you. So I kind of have to yank all the sexy out of that and think about this in the most technical, the most ethical terms when doing this sort of design. And the question becomes, though, how do we find that other user, and how do we tell that other user, this is how you connect my toy to my toy? We're going to be sharing probably some sort of URL and a special code to be able to connect and then to identify. And how you pass that to the other user is going to be up to you. You want to tell them in plain text, fine. You want to encode it in a one-time pad, also fine. But it does offload a little bit of our responsibility, once again, for simplicity's sake. And I'll be going into more about the security of this later. Okay. For the computer-computer interface, here we go. Here's the security. The protocol to talk between these two things will not be raw Buttplug. It will be something that I will be building and presenting here and talking about how we build Teledildonics protocols, but it will not just be the same thing that Buttplug uses to talk to hardware, or that I'll talk about in a sec about how the client and server talk to each other. That's because Buttplug is made to only access hardware. It is not made to share hardware. I did not build any permissions into it because that's not what it's made to do. I'm trying to keep things inside Buttplug as simple as possible because there is so much work to be done in how we deal with the toy protocols themselves, and how we talk to Bluetooth on all of these different platforms. Like, it's different on Mac, Linux, Windows, Android. It's the same on Mac and iOS, at least. But otherwise, though, there's so many differences to deal with and so many things to think about that if I had to put another permissions layer on top of that, it's going to muddy up the hardware. So we want to make sure that Buttplug does exactly what it's supposed to, and then anything we build on top of that will be new and specific to the thing that we're building, but Buttplug just does the thing it does well. Next slide. Okay, so the network types we can talk over. So we're going to try two of these. There's going to be WebSockets. First off, so WebSockets are really just HTTP requests that are flying back and forth with a little bit of statefulness. What that means is, like, when you hit a website, you ask for a whole bunch of shit, but you do it all at the same time. And so you get your images back, you get your, like, HTML back. Excuse me. But all of these are stateless connections. It's just like you get the page, and then the page requests a bunch of images and other media and whatnot. We need to actually know, okay, I am connected, I am alive, I am talking to this server. Okay, wait, I closed my web browser. I don't know that I'm talking to this server anymore. Like, if you load a web page and you close your browser in the middle of it, all the web server knows is, oh, like, whatever image I was sending died, but I'm also not getting any more requests. I don't care. I'm going to go serve these millions of other people. With WebSockets, you can actually see, okay, no, this person is no longer connected, and that is super important, because if we drop a connection, we want all of our toys to stop. We just want everything to turn off, because what we have delegated the consent and usage of our toys to this technology and possibly to another user through that technology. And once that technology is gone, once that software or that application has shut down, our trust has shut down too. And so we want to make sure that everything that came with that trust is removed. The other way to talk is WebRTC. WebRTC is peer-to-peer, which means, like, with WebSockets, you're going to have to go to a server outside, and then that server is going to talk to the other user. The other user is going to send a command back. It's going to go through the server, talk to you. With WebRTC, you're both talking to each other directly. However, you're talking to each other directly once you find each other. Finding each other actually requires a server in the middle to tell you both where you are and how to get to each other. That's what we call a stun server. And that's used for NAT punching, which is basically a way of finding a way of saying this person is here even if they're behind a router or something like that. So we have to hit that server once to get everyone finding each other. But once we're there, then you can talk to each other, and there's no one else in the middle. WebRTC is built into browsers, and this includes Firefox, Chrome, I believe Safari has it now. It's a pretty popular technology, and so it's kind of everywhere, and it's pretty handy. It's like I said, it's mostly used for video and audio, so it's popular for like web conferencing and whatnot these days. But it also does have data channels that we can ship stuff over, and there's already super easy libraries to use with it, like Pure.js, which is what I'll be using. And of course, then there's that whole security part that's kind of important. So metadata here is a problem, and this is something that Sarah Jamie Lewis, an amazing security and privacy researcher who wrote this wonderful book that I had over here and forgot to pick up. Anyways, where'd my copy of... Well, Sarah wrote this amazing book called Queer Privacy that is all about identity and metadata and privacy on the net. It's or she edited the book, and it has a lot of really interesting stories from different queer trans authors about online privacy. So Sarah runs the Open Privacy Initiative too, which I highly recommend checking out. And she deals a lot with metadata though. So, and metadata security is just important as the actual toy commands that are flying over. So with Teledildonics, if you connect to a server and that server has been hacked somehow and someone else can see you're connecting to someone else, that's the metadata. That's not like, or even if they can see you're connecting to the server at all, that comes with the context here. If you are connecting to a Teledildonics server, it can be fairly easily assumed, even if you're just checking it out, that you want to fuck online. And so you suddenly gain this context that is very important to the connection, and very important to your usage of it. And that's kind of a scary thing to have to deal with. On top of metadata, and this is just thinking about the security stuff we have to deal with when building a Teledildonics app, man-in-the-middle attacks, or user-in-the-middle attacks, as we can go here, are definitely a problem. Hijacking haptics is well beyond just, oops, I lost my credit card. We tend to think a lot about security and monetary policy right now, but actually dealing with intimate haptics and hijacking and whatnot, it comes up constantly when people are talking about sex toys in online contexts and applications, but it's not something we really have good rules about it yet. So it's definitely something to think about when building these things. So for what we're trying to do with this simple application, it's not going to be the most secure locked down thing in the world. We aren't going to be routing everyone through an onion router or something like that. Though that is possible. Once again, Sarah Jamie Lewis, check out her Onion Dildonics project. Really cool work about that. What we're going to try to do is really what's sort of a bare minimum of running secure connections through the system. Any web page is going to have to be HTTPS. WebRTC has to run securely, but those are not really great. I mean, that is once again bare minimum. It's not a great amount of security there because it's easy to get certificates places. There's Let's Encrypt and stuff now. So this is not guaranteeing the user that only they will ever see their session or any other really guarantee on security. It's just saying we'll at least not fly shit in the clear. And also, since this system is really only made to be used by two people, you can move it to whichever server you want, lock down things yourself, but we are once again depending on the user to do that, and the user would have to be incredibly technically savvy to do that. Not only would they have to be technically savvy, they would have to keep their technical savvy while also wanting to fuck desperately with their software at some point. Like, that's the thing, is if you decide you want to use Teledildonics software and then, oh wait, I need to do the security thing, but I'm kind of raring to go now, that can really fall out of the thought chain of, oh wait, but I needed to set up this firewall, set up these like forwarding rules, make sure only this person can access this, so on and so forth. So unfortunately, when you are doing Teledildonic app design, you're probably like hopefully not also raring to go yourself, so you actually have to think through this for the user. And you do the way that I usually put this is that it's empathy for the horny user, because the user's not going to want to think about that when they're using your application. Finally, the user will need to share secrets manually and trust whoever the user is sharing them with. We don't really have a system for that with this simple application, so we are trusting them to find whatever way they'll do that. I mean, that could be through some sort of secure messaging signal or something like that. I have a feeling most of this stuff's going to go through WhatsApp or iMessage or Telegram or something. But yeah, once again, not a completely locked down, secure way to do it. But there's only so much we can do here if I want this video series to last under like 40 hours. Okay, so that is it for our design considerations. That is what we are looking at developing in parts 3 and 4 of this lecture. In part 3, we'll make the single player version of it, so we'll just remake the Buttplug playground here, and this will get us familiar with the Buttplug part of things, and then in part 4 we'll go ahead and implement the protocol on top of that, and by the end of part 4 we should have a complete Teledildonics app ready to go. So let's talk about the insides of what Buttplug are. We aren't actually going to look at code here too much. This is really just going to be some architecture and terms. Okay, so Buttplug basics. Buttplug is a system for discovering and accessing computer-controlled sex toys. All we do is provide a communication bus abstraction layer. That's it. And there's really... The only thing that, excuse me, that Buttplug does that is special to sex toys is that it has some certain messages that talk about sex toy haptics. So it has certain ways of doing vibration and stroking and whatnot, but you could really rip the top off of this and just make this a generic device abstraction layer. It's something I'm looking at doing later this year. So if you wanted to access any Bluetooth device, or if you wanted to make a like EEG plug, if you just have a whole bunch of EEGs or something like that that you wanted to hit that you all want to look the same, Buttplug can totally do that too. But for now, we're going to stay with sex toys because this is Teledildonics 101. So yeah, it runs over all these different COM buses, Bluetooth, USB, serial. No one's handed me a FireWire sex toy yet, thank God. I haven't had to run over parallel yet, but we can always add those things if we need to. It's an extensible system. It runs on pretty much every OS. For Windows, we're using UWP Bluetooth. For Mac, we're using Core Bluetooth. Linux, we're using Blues. iOS, once again, Core Bluetooth. Android Bluetooth, for as much as it ever works. So we have different solutions for each platform right now, but we're trying to get to the point of having a single code base that lives on most of those. It's written in Rust, but that comes later. And as I already showed earlier, we support about 140 pieces of hardware right now. Buttplug, once again, not a Teledildonics system by itself. Technically, you could do it. People have in the past by forwarding some of the messages that we send that I'll talk about. I really don't recommend it because there's no security there. People can send stuff that you might not want. They can just like throw your toy all over the place or whatever else. Buttplug is meant to be built under another layer of security, and that's what we're going to be doing. It just concentrates on making sure you can find your hardware and you can control your hardware. It does have a tiny bit of security at the protocol level, because I will say that some sex toys, once again, like the goddamn Fleshlight launch, can actually be kicked into firmware reload mode through software alone. There's no user gesture on the Fleshlight launch to kick it into its bootloader, and once it's kicked into the bootloader, it will not kick back out until you reload firmware, which is actually kind of hard. So you can brick some of these devices using nothing but Bluetooth. It's not really a full brick, but it's enough that it's really going to annoy a user. So you kind of we are careful about how much of that part you can access. But overall, though, still expect not much in the way of security from Buttplug. It is really just for that low-level access stuff, and you really need to take care of the rest of it yourself. What is Buttplug internally? So Buttplug consists of a few different pieces. There is the server. And I use a client-server nomenclature here, even though this may not actually be happening on a network. It's just more of how I kind of visualized things when I was building it. This does kind of confuse people, but a client and server can be running in the same application, in the same process even. So a server manages the device connections. The server is the part that actually talks to hardware. So it's the one that goes out, finds all the Bluetooth devices, finds all the USB devices, things like that. And then it's the thing that also controls them. So it is what translates our generic, just to make this thing vibrate, into, okay, here's the exact command the toy needs. And that's all it does, but when I say that's all it does, that's actually a super complicated thing to do, because it needs to possibly orchestrate multiple toys at the same time. It needs to deal with all these different operating systems and whatnot. So it's by far the most complicated part of the system, but it's also, as an app developer, you should really never have to deal with this all that much. What you'll be dealing with is this thing called the client. The client is the API to the server. So it is what makes life easy. So you don't actually have to send all of our low-level commands. You can just have the client connect to the server, talk to it, and find your have it scan for your toys. You get your toys back via certain events or something that'll just say, okay, I found a toy. Okay, wait, no, this toy disconnected. Things like that. You'll get all that through the client. And then once you have that toy, you can actually tell that toy, okay, vibrate. The client does all the work to turn that into something the server understands. The server does all the work to send it down to the hardware. So you will probably never really have to deal with anything outside of the client unless you're doing something special with the server. And I try to cover most of that for people. If you do ever want to add new toys, or build your own toy and add a new protocol or something, that also happens down in the server. Feel free to talk to me if you want to do that. It's kind of complicated right now, but hopefully it's getting easier. Like I said, server and client do not necessarily mean they are talking over a network. That's just the abstraction that I have. Now, they can be remote. They can be separated. Because the idea is that any application written with Buttplug should be future compatible. So that means there's people that wrote some games and stuff using the very first version of Buttplug back in 2017. Those should still work, and not only should those still work, they may actually work with hardware that did not exist back then. Because they knew to call this vibrate command or whatever else. So when new toys that come out that vibrate, as long as they are connecting to a newer version of the server, as long as it's not built in or something like that to their program, people can keep upgrading the server, and we keep that server backward compatible. So they can, their game can access future vibrators or future other sex toys or whatever else. So we do all that work in the server too. Like I said, server's really complicated, but that's why you would want to have it have a program where you have the client in your application, but it may not also involve the server. And so the server itself would, in that case, exist in this application we have called Interface Desktop, which is the user GUI for the Buttplug server. It's just a little Electron application here that handles setting up how to talk to the server and whatnot. That will become more someday, but for now, that's what it does, and it's pretty handy at it. Going back to PowerPoint. Now we talk about our devices. So the devices we talk to, we can connect to them multiple ways, and devices are made up of two different things. There is the way to talk to them, their protocol, and then there is their implementation, which is how do we talk to their Bluetooth or their serial, whatever else. We combine these two things and ship that protocol over that implementation, and that's how we talk to the toy in the server. On the client side, you'll also have a version of the device, but all you're going to see there is it can vibrate, it can rotate, send it those commands. That's it. You don't have to worry about any of that on the client side. And the client and server communicate via a protocol, which I will talk about right now. So the way the client and the server talk depends on, are they sitting in the same process or are they remote? The whole system revolves around this core protocol that's known as just the Buttplug protocol. You can actually find out more about it by going to buttplug-spec .docs.buttplug.io. Super simple URL there, I know. So this, we actually have a standard for the protocol. Usually, once again, you will never need to deal with the raw protocol. This is how the client and the server talk to each other. If they're sitting in the same process, they may be using like structs or objects or just some sort of data. If they're in different processes, they'll turn this into JSON or something like that. But we just have all these different type of messages that Buttplug talks for saying, hey, I'm a client. Hey, I'm a server. Hey, I talk this version of the protocol. And then we get down into the things like, yeah, here's how we stop devices. We use vibrate command to make a device vibrate. And all the vibration command does is says, I would like this device to vibrate at these speeds, and we have devices that have multiple motors, for instance. So like the Mystery Vibe Crescendo has 6 different motors, and within a vibrate message we can actually control all 6 of those. We can control one of them, we can control 3, we can control like the 3 in the middle, so on and so forth. There's tons of extensibility there. And we almost all of these messages are API endpoints in the client. So you'll be able to access. So all you have to do is call the vibrate command, and you can send like those motor indexes and motor speeds yourself. It's pretty easy. You don't have to deal with forming those messages yourself, almost ever. Anyways. Like I said, yeah, right now we serialize down to JSON. We're looking at maybe going protobuf or something too, but we don't really ship a lot of data over the line. Buttplug is not that complicated of a protocol. Most sex toys don't update very fast. We're talking like 20 hertz on a good day with the wind blowing in the right direction. So sex toy is not super complicated at the moment. There are some fucking machines that are going to be coming out soon that do that use linear actuators and stuff. Those will move a little bit faster, but even so, I don't foresee us having too much of a problem with that. And yeah, there's our message types. So we have status messages like, yes, I got the message. Okay, this message fucked up. Yes, I'm still talking to the server. Handshakes, which just tell the client and the server about each other. Device enumeration for scanning and finding devices. And then finally the commands of make the device do something. So if you wanted to actually see what the Buttplug system looks like as a graphic, here is a very complicated one. So what we are going to be writing is this stuff over here. This app right here is what we are going to be spending our time in parts 3 and 4 working on. It is going to use the client API. The client, so this will, our app will sit on top of the client API, and it'll do start scanning, stop scanning. Okay, I got a device. What can I do with it now? This red line right here is what I've been talking about. This is where the gap between the client and the server are. For our usage with a web browser using web Bluetooth, it's going to be in process. So everything like what I was showing you with Buttplug Playground earlier, that was the client and the server both running in the web browser as JavaScript in a web page. We can do this over WebSockets if a user does need to access stuff through Interface Desktop, and it looks 99% the same. The only thing you do to change a Buttplug application from using an in-process system to using an out-of-process system like WebSockets or inter-process communication pipes or something like that is to just change this connector object. So whenever you make a new client, you say, I want to connect inside the process, and you'll use what's called an embedded connector. If you want to connect out via WebSockets to Interface Desktop, you just use a WebSocket connector. And that's the only thing you change. All of the other commands run through that connector, and it handles all of the data transfer for you. So you really just have to change one line of code to change how you are going to talk to these things. And your application can do both, too. It's fairly easy to just say, okay, if the user wants to use WebSockets, take this branch and hook up with the connector. If they want to use it in the process, use the embedded one, go with this connector, and you're ready to go. Once we get into the Buttplug server, that's when things get a little more complicated because we've just got so many different types of applications and, so many types of devices to deal with and so many buses they may talk to. So we'll start, let's just say you've sent a start scanning command to the server. So it needs to go through and look at all of the different buses it supports, Bluetooth, USB, serial, and see if there's any devices on them we want to know about. So each one of those things is handled by this device manager object right here. So you'll have a Bluetooth device manager, a USB device manager. For instance, Xbox gamepads use their own special protocol called xInput that's on Windows. And it has its own device manager. So that's how we find gamepads and control their vibration, is through the xInput device manager on Windows when we're going native. With Playground and with Buttplug.js, you'll be using a web Bluetooth device manager. You don't really need to know that, though. That will, or at least not to build this thing. The web Bluetooth device manager is automatically added to any browser that has web Bluetooth when Buttplug.js loads. So anyways, Oh, wow. Okay, so the device... I'm sorry. There is only one device manager. I stopped too early there. The device manager handles what we used to call device subtype managers. These are now called device communication managers. The device communication managers are what are the USB, the Bluetooth, the serial, so on and so forth. So these all aggregate under a single device manager. So let's say you say start scanning. That goes from your app to the client. The client turns that into whatever the server needs, whatever the message needs to get to the server. The server sees, okay, that's a start scanning message. The device manager cares about that. The device manager goes, okay, I have all of these different subtype managers. Let's tell them how to start scanning. Let's say this one's the Bluetooth manager, so it will start doing a Bluetooth scan. If this one's an xInput manager, the way gamepads are scanned for, you just call a function, it hands you back all the gamepads it knows. There's no hot plugging events or anything like that really for xInput, so you actually have to keep calling that multiple times to see if someone realized, okay, I hit start scanning, oh, then I need to turn on my gamepad. So we handle all of that inside the server for you. And that is kind of how the device manager system works. Once, let's say, you found a gamepad, and that's going to come up from that X input manager. You're going to pass, the server will pass that through to the device manager. The device manager goes, okay, this is a new device I need to manage. It sends that to the server. The server goes, okay, we have a new device. Client needs to know so that our application can know, and it handles sending all that information back. And so let's say then you want to make the gamepad vibrate. Once again, in your app, all you do is say send vibrate CMD. And client handles that, sends it to the server. The server sends it down through a protocol to turn it from our vibrate CMD command into whatever the gamepad wants, whatever the dildo wants, something like that. And then finally it goes to our device implementation, and it goes to the device, and your device starts vibrating. That is how Buttplug works. So there's a lot of wheels turning inside of this. The nice thing is you don't really need to know about most of them once you're into the implementation side. I will rarely, if ever, be talking about exactly how the server internals work over the next two lectures, but I wanted to give people a full view of the system in this. And I believe that is it. So, wow, I still talked for 80 minutes. This is a lot of information though, and I'm hoping it's going to be useful for people in the future. So what are we looking at doing next? We'll be coding for the next two sessions. I've never live coded before, so it's going to be really interesting. Part 3, we'll make the single player version of the Teledildonics app. So just hooking up different devices, seeing what they do, and being able to make them do that thing. And part 4, we'll be able to load the app, and someone else will make the device do whatever it is it can do. And after that, we're going to call Teledildonics 101 done. And I'll be moving on to Teledildonics 201, at which point we'll be hooking it up to all sorts of stuff. That's going to be a little bit more unstructured, a little bit more technical, but also I'll be going, once again, through all of those design steps every time, just to talk about what we expect of the user when they're using, say, a chat app versus a VR app or something like that. Yeah, and like I said, first time live coding on stream, so it's probably going to take me a little bit of time to prepare all of this. But yeah, I'm hoping to be doing the next the part 3 lecture middle to end of this next week. So looking at probably like March, sometime like 25th to the 27th probably. And that is it. If anyone in the chat has any questions or anything like that, please let me know. I'm going to go ahead and jump over there now and ask. And I'll wait here a couple of minutes. And if you're catching this later and you have any questions, feel free to either contact me on Twitter or leave comments on the YouTube videos. I do, unfortunately, read the comments. So, and I usually try to respond to questions. Like, I'm still getting questions from the original Fleshlight launch video I did a little over 3 years ago now. So I usually try to keep up on those as much as possible. Yeah, so it doesn't look like there is much in the way of questions coming out of the chat at the moment. So I'm going to go ahead and call us good for today. But thank you so much for watching. I will be announcing the next video on all the social medias and whatnot. Once again, if you could please like and subscribe. Really trying to get near that 1,000 subscriber mark so I can, well, I'm never going to be able to monetize this. What am I saying? Butt plugs. But yeah, so great. I will see you again later this week. And until next time, keep butt plugging.